Alright guys, so we're going to go ahead and work on expanding and factoring algebraic expressions. Our objectives are we're going to use the distributive property to expand algebraic expressions. I forgot my second objective is that we are going to use greatest common factor to factor algebraic expressions. So, two new vocabulary words. Expand means to write an expression that uses parentheses as an equivalent expression without parentheses. So, for example, if you start with 4 parentheses y plus 1, you would expand it and make that 4y plus 4. Now, factoring is the inverse of expanding. To factor means to write an expression that does not use parentheses as an equivalent expression with parentheses. So saying if you started out with 4x plus 4, you would factor it and rewrite it using parentheses as 4 parentheses x plus 1. Alright, so we're going to go ahead and start expanding algebraic expressions. So here it's telling us to expand 2 times r plus 8. All this is saying, guys, is that you have r plus 8, 2 times r plus 8. So if we were going to just sit here and put together our like factors and simplify it, we would call this 2r plus, we would combine our r's, and then we could combine our 8s and make this 2r plus 16, which is exactly what we're going to do when we expand it. What I like to do is I like to draw these little arrows and say 2 times r is 2r, keep my same sign, so plus 2 times 8 is 16. And as you guys can see, I got the same exact answer of 2r plus 16. So let's go ahead and try another one. Down here I have expand 3 times k plus 6. So all this means, guys, is that we've got this k plus 6 3 times. And if you wanted to go ahead and simplify that by combining your like terms, let's see what we would get. So what I'm going to do is I'm going to do 3 times k, which is 3k, plus, because I'm keeping my same sign, 3 times 6, which is 18. Alright, so let's go ahead and try a guided practice. Go ahead and copy all of these down, pause it, and see how you can do. So on the first one I have 3 times x plus 4. So I'm going to do 3 times x, which is 3x. Keep my same sign, so plus 3 times 4, which is 12. So moving on to my second one, I have 6 times 2x plus 3. So I have to do 6 times 2x, and 6 times 2x is 12x, plus 6 times 3, and 6 times 3 is 18, so I get 12x plus 18. On the third one I have 2 times 7 plus 6x, so I'm going to do 2 times 7, which is 14. Keep my same sign, so plus 2 times 6x, which is 12x. Alright, and the last one, number 4, I have 5 times y minus 3, so I'm going to do 5 times y, which is 5y. Keep my same sign, so minus 5 times 3, which is 15. So again, I'm expanding the expression because I'm starting out with a parentheses and I'm taking it away. Alright, so more guided practice. They want you to state whether each pair of expressions are equivalent. So here on number 1 I have 6 times x plus 5 and I have 6x plus 30. So what I'm going to do is I'm going to go ahead and expand this. 6 times x is 6x plus 6 times 5 is 30. So yes, these are equivalent expressions. The second one, I have 7 times x plus 3 and 21 plus 7x. So I have 7 times x, which is 7x. Keep my same sign, so plus 7 times 3, which is 21. Is 7x plus 21 equivalent to 21 plus 7x? Yes, it is. All right, and on the last one, I have 4 times y minus 4, and I have 4y minus 4. So I'm going to go ahead and expand this and do 4 times y, which is 4y, minus 4 times 4, which is 16. So 4y minus 16 is not equivalent to 4y minus 4. All right, so now that you feel kind of comfortable with expanding an expression, we're going to go ahead and work on factoring an algebraic expression. So remember, factoring means that we're going to write an expression that does not use parentheses as an equivalent expression with parentheses. So these don't have parentheses. So what I have to do is I have to find a common factor for 2y and 10. So I know to get 2y, I would have 1 times 2y, or y times y. And to get 10, I could do 1 times 10 or 2 times 5. So as you can see, they have this little 2 in common. So what I'm going to do is I'm going to factor out my 2 and start a parentheses and say 2, this 2 times what would give me 2y? Well, 2 times y gives me 2y. Again, I'm keeping that same operation that they gave me, so that's addition. And then I'm going to ask, okay, 2 times what would give me 10? Well, 2 times 5 would give me 10. And then I'm going to close my parentheses. And I can always check to see if I'm right by expanding it again and saying, well, 2 times y is 2y, plus 2 times 5 is 10, and that is what we started with. And so our answer for factoring this is 2y plus 5. All right, so let's go ahead and work on the second one. So they're telling us to factor 6z minus 9. Well, to do that, I need to know what factors 6z and 9 have in common. Well, 9's pretty easy. I have 1 times 9, and I have 3 times 3. For 6z, I could do 1 times 6z. I could do 2z times 3z. Alright, so as you can see, we've got a 3 in here that we can work with. So what I'm going to do is I'm going to pull out that 3 and start my parentheses and ask myself, okay, 3 times what gives me 6z? I already know from over here, 3 times 2z would give me 6z. So now I'm going to keep my same operation, which is subtraction. And 3 times what gives me 9? Well, 3 times 3 gives me 9. And so then I can close my parentheses. And again, I can check it by factor or by expanding it and saying, well, 3 times 2z is 6z minus 3 times 3 is 9. So we did do it correctly. Alright, so guided practice. Remember, you just need to find a common factor that you can pull out of both and then start your parentheses. So on the first one, we've got 3x plus 3. So obviously these both have a factor of 3. So I'm going to do 3 and start my parentheses. And 3 times what gives me 3x? Well, 3 times x. Keep my addition sign. And 3 times what gives me 3? Well, 3 times 1 gives you 3. So you should have 3x, or 3 times x plus 1. So on this one that we have 4x plus 6. And so what we're going to do is I can see they both have a common factor of 2. And so I'm going to ask myself 2 times what would give me 4x? Well, 2 times 2x will give us 4x, and I keep my same operation, so keep my addition. And 2 times 3 will give me 6. So I'm going to put in my 3 and close my parentheses. All right, for number 3, I can see that they actually both have a common factor of 4. So I'm going to pull out my 4. And 4 times 3t would give me 12t, and I keep my same operation, so minus. And 4 times 2 will give me 8. All right, then the last one on this page is 15 plus 5q. And again, we can see that they have a common factor of 5, so we'll pull that out. And 5 times 3 gives me 15, and I keep my addition sign. And 5 times what will give me 5q? Well, 5 times q will give you 5q. So you should have 5 times 3 plus q. All right, so we're going to do some more guided practice. This time we're going to state whether each pair of expressions are equivalent again, but this time we're going to do that by factoring one of them. So on the first one I have 8x plus 6 and 2 times 4x plus 3. So I'm going to go ahead and do a common factor of 2 and say 2 times 4x would give me 8x plus 2 times 3 gives me 6. And that's the same expression, so yes, these are equivalent. On the next one I have 5x minus 10 and 5 times x minus 5. So I'm going to pull out this common factor of 5, and 5 times x gives me 5x minus 5 times 2 gives me 10. And so these are not the same expression, so these are not equivalent. All right, and the last one is 3 times x plus 5 and 15 plus 3x. So I'm again going to go ahead and pull out my common factor of 3 here and make this 3 times, well, 3 times 5 is 15, plus 3 times x would give me 3x. So is 3 times x plus 5 equivalent to 3 times 5 plus x? Yes, it is. All right, guys, that was it for this section. Please make sure you write down any questions that you have, and we're just going to practice this as much as we can.